welcome to the Big Bang. Here, let's find both the particle velocity and the particle acceleration in angular kinematics. To do this, we will need to reflect on the angular velocity and accelerations on non-tangent motions. I will keep the equations for the velocity and the acceleration here for reference. Think of a particle p moving along a path. Again, we have position vector r, but now we also have the unit vectors e theta tangent to the path and er in the direction of the path. Notice that e theta and er will be orthogonal. We can then write er as cosine of theta, sine of theta, and 0, and e theta as negative sine of theta, cosine of theta, and 0. Since they are orthogonal, their dot product is 0, as expected. But notice how when we take the derivative of er, we get e theta times the derivative of theta. And when we take the derivative of e theta, we get negative er times the derivative of theta. This will be very useful in solving the particle's acceleration. Let's first find the particle velocity though, since that's also important. We know that v equals omega cross r. Let's replace these two variables. Omega can be written as theta dot n, and r can be written as r er. This cross will equal theta dot times r in the orthogonal direction, which is e theta. Now, the component along er should only be r dot. This gives us the particle velocity. V equals theta dot r e theta plus r dot er. The first term is the tangent velocity, while the second term is a normal velocity. Finally, let's now face the particle's acceleration. We can write the acceleration as v dot, which represents the derivative of the velocity with respect to time. We have just found the particle velocity actually, so let's go ahead and use it. Taking the derivative of the expression we found above, we get this kind of long expression in blue. From what we learned just a bit ago, we know that the derivative of er is e theta times theta dot, and the derivative of e theta is negative er times theta dot. We can now simplify that expression and rearrange it a little bit. We get our final particle acceleration expression, which is the one boxed in yellow. Keep in mind that the first term is a normal component of the acceleration, and the second term is a tangential component of the acceleration. This was quite a bit, so I'll stop right here and I'll see you next time.